Hi everybody, welcome back. This is going to be our diagram, our six-stage diagram on the formation of a mid-latitude cyclone, also known as an extratropical cyclone. And this is already finished, so you can do it in whatever order or whatever pace you want, but I'm going to walk you through what's happening in each of these stages right here. All right, I was going to redraw it again, but this I did this before, and I figured this is pretty good the way that it is, and so why mess with it? You can just write it down at your own pace. All right. Well, in stage one, right here. By the way, let me back up. Each of these blocks, which on your sheet are probably empty right now, but each of these blocks, think of it as being a three-dimensional, not a cube, but three-dimensional like chunk of the atmosphere. All right, like a rectangular cube of the atmosphere. And the far edge, that edge right there, where it's dark, that is like the heavy line, heavy black line. Think of that as being the ground, and the nearest, well, this might be the easiest to see. See where it's see where the crosshatch is right here? That's the nearest to us, so it's like the top of the atmosphere. All right, so think of it like that. All right, well, in stage one, we have, and label this as such, we have what's called a stationary front. Now, you probably remember from fronts that a stationary front is one where cold air mass and a warm air mass meet, but they don't actually push each other out of the way. Instead, they start to move in opposite directions parallel to that front line right there. And this is the front line. And of course, this is a symbol for a stationary front. You've got blue triangles on one side and red semicircles on the other. And so these two armies, you can think of it as being, and really that's where front comes from. It comes from a military word. These two armies say, okay, well, we're not going to push you out of the way. You're not going to push us. So we'll just go around and you just go around and then everybody's happy. Okay. So they start to move kind of parallel to each other on opposite sides of the front. But as we know, winds don't move in a straight line forever because of the Coriolis effect. So in stage two, we have what is, I just call like a wave forming. All right, this straight front line is no longer straight, but this kind of had like, you had this little bump up right here, or this wave. Why is that? That's because warm air is pushing up. Warm air and cold air are kind of rotating around each other. They're not moving past each other, or they're not anymore, but this is starting to curve that way, and that's starting to curve that way. So you have the warm air pushing in towards the cold air, and the cold air pushing towards the warm air right here. All right? We don't really have any fronts here, but there is kind of this wave. All right? You might call that this kind of the beginning of a trough right there. All right, between cold and warm air. All right, our third phase. We call it cold and warm fronts form. Now you know from fronts that a cold front is where cold air is pushing into warm air, and that's exactly what we have here. See, the cold air is pushing into where the warm air is existing. That's why we have the blue line with the blue triangles on it. And here where we have warm air pushing into where cold air is, that's called a warm front. Except the only difference is the cold air is trying to slide underneath the warm air, and the warm air here is trying to rise up over top of, I'll mark this up a little bit with orange. The warm air is going to try to rise up, ooh, I don't want to do that, over top of the cold air. Make my pen a little bit smaller. Like that, all right? We know as warm air rises up, it cools and condenses. And so we have a warm front, you've got light rain. Here, where you've got cold air pushing underneath warm air, forcing it to rise up, it's going to rise, cool, and condense as well. So both of these fronts contribute towards warm air rising up and cooling and condensing. So that's stage three. Stage four right here, we finally have something called an occlusion. And what an occlusion is see how this cold air has kind of touched this cold air over here, kind of like a pincher, sort of? Well, this warm air, indicated by the dotted line, the warm air is being scooped skyward. And so it's being cut off from the ground. So where you have that seam right there is what we call an occluded front. All right, and so where is the warm air going? It's going upwards. And as it does that, warm air that goes upwards continues to cool and condense. And you're going to see a lot of condensation right there. So we have an initial occlusion. That's an occluded front line. In stage five, and by the way, you might be looking at the first stage and saying, we've got about equal cold and equal warm right here. Wow, looks like we got a lot of cold, and where did all the warm go? Well, the warm is still there, but it's being scooped upwards. So it's closer to us than the cold air because the cold air is pinching underneath. So this cold air here and the cold air underneath here have kind of met in this occlusion, in this seam, and all the warm air has been forced upwards. As it does that, it continues to cool and condense. Now I have that drawn in green right here. That is the condensation. But that, of course, that's what produces the rainfall. Right? So the warm air is being scooped upwards. The cold air is pinching underneath it. And finally, when all the warm air has been scooped to the top and all the cold air has gone to the bottom, what do we have? We have stable conditions. Why is that? Well, the warm goes to the top and cold goes to the bottom. That's where they want to go, and so there's no more pushing of anything out of the way. So there's a little bit of a rotation left, but all the warm air is now nearest to us, and all the cold air is furthest away from us. Well, from our point of view, it's on the bottom. So we went from cold and warm air being next to each other through all these stages to being warm air on the top and cold air on the bottom. But it's really this process of warm air being shoveled upwards that causes the cyclone to be seen. And really, this is that comma shape that is so typical of mid-latitude or extratropical cyclones. The last thing I'll show you is a short little animation that I did that hopefully kind of shows this taking place, and you can sort of envision it a little better, even if my diagrams or your diagrams didn't really help. All right, so I'm going to go ahead and play this. I'm going to try to. There we go. All right, so there's our stationary front. Then we have our wave forming, still sort of a stationary front, I guess. Now two definite cold and warm fronts. The warm air is condensing. There's the occlusion right there where the cold air is pinched underneath. Further occlusion and more of that comma-shaped condensation. And finally, we have stable conditions here at the end, where all the warm is at the top and the cold is at the bottom. So I'll see if I can go back and play that one more time for you. Stationary front, stage 1. Our wave forming, stage 2. Stage 3 is our cold front and warm fronts. Stage 4, you barely have that occlusion taking place where the cold air is pinched underneath. Stage 5, more occlusion and more rising, cooling, and condensing. See how the warm is going to the top. And stage 6, stable conditions where warm is at the top and cold is at the bottom. So that's your 6 stages of mid-latitude cyclone, also known as an extratropical cyclone. And I'm going to ask you to make sure you follow along and copy that down and show it to me, of course. But if you have any questions, please make sure you see me. And thanks for watching. I'll see you on the next one.